In this session, we're going to delve deeply into the fundamentals of Test Automation Architecture, or TAA, which serves as the backbone for any successful automated testing strategy. At the heart of this concept is the generic Test Automation Architecture, often referred to as GTAA. This high-level design framework provides a comprehensive view of how test automation interacts with various systems within your project, such as the system under test, SUT, project management systems, and test management tools. By understanding the major capabilities and components within a TAA, we can craft a more effective and efficient automation strategy that is aligned with the specific needs and goals of our project. The goal here is to not only streamline the testing process, but also to ensure that our automated tests are robust, reliable, and scalable over the life cycle of the project. The Generic Test Automation Architecture, or GTAA, outlines several critical interfaces that are essential for ensuring seamless interaction between the test automation framework and the various systems it connects with. Let's start with the SUT interface. This interface is responsible for managing the direct connection between the system under test and the test automation framework. It's crucial because it dictates how well your automated tests can interact with the actual system, whether it's accessing data, triggering events, or verifying outcomes. Next, the project management interface plays a vital role in tracking the progress of test automation development. This interface ensures that the development of your test automation framework is aligned with the overall project timelines and objectives. By monitoring this interface closely, project managers can ensure that the automation efforts stay on track and adapt as necessary to meet project deadlines. The test management interface is another key component, responsible for mapping test case definitions to their corresponding automated test cases. This interface ensures that there is a clear, organized structure for managing tests, making it easier to scale your testing efforts and maintain a high level of organization as the number of tests grows. Lastly, the Configuration Management Interface integrates with Continuous Integration Continuous Delivery (CI/CD) pipelines, manages different test environments, and handles the various pieces of test where needed throughout the testing process. This interface is vital for supporting continuous integration practices, ensuring that tests can be run consistently and reliably as new code is integrated into the project. Building an effective test automation architecture involves integrating several core capabilities, each provided by specific tools within the framework. The first of these is test generation. This capability is particularly powerful as it automates the design of test cases based on predefined models. By leveraging model-based testing tools, you can significantly speed up the creation of test cases, reducing manual effort and ensuring consistency across your tests. However, it's worth noting that test generation is an optional capability. It's most useful in projects where the complexity and volume of test cases justify the investment. The next capability, test definition, is fundamental to any test automation effort. This capability supports the definition and implementation of individual test cases and larger test suites. What's important here is that it allows you to keep test definitions separate from both the system under test and the tools being used. This separation is crucial for maintaining flexibility and ease of updates, as you can modify or expand test cases without affecting the underlying system or tools. Test execution is another critical capability that directly impacts the efficiency of your automated testing process. This capability includes running the tests automatically, as well as logging and reporting the results. An effective test execution tool will allow you to schedule tests, manage execution environments, and capture detailed logs that can be analyzed to quickly identify any issues that arise during testing. Finally, test adaptation is what enables your automated tests to interact effectively with various components and interfaces of the SUT. This capability involves using adapters that connect the automation framework with APIs, protocols, and services used by the SUT. By providing the necessary functionality to adapt your tests to different environments, test adaptation ensures that your automated tests remain relevant and effective even as the SUT evolves. Designing a test automation architecture is about more than just selecting the right tools. It's about integrating these core capabilities into a cohesive framework that aligns with your project's needs. First and foremost, you must ensure compatibility across the various systems your TAA interacts with. This includes making sure that the tools and frameworks you choose can seamlessly integrate with the SUT, project management tools, and any other systems involved in the testing process. Optimizing the test generation and execution processes is another critical consideration. By choosing tools that streamline these processes, you can significantly reduce the time and effort required to develop and execute tests. This optimization not only accelerates the testing cycle, but also improves the overall quality of your tests by reducing the potential for human error. Adaptability is also key. Your test automation architecture should be designed with the flexibility to adapt to changes in the SUT or in testing requirements. This might involve selecting tools that can easily be updated or reconfigured, or it might mean building in redundancies that allow your testing processes to continue uninterrupted, even as the project evolves. By ensuring that your TAA is adaptable, you can future-proof your testing strategy, making it easier to scale and adjust as your project grows. In conclusion, understanding the major capabilities within a test automation architecture is essential for building a robust and effective test automation framework. The Generic Test Automation Architecture, or GTAA, provides a structured approach to integrating key capabilities such as test generation, execution, and adaptation. By focusing on compatibility, optimization, and adaptability, you can design a TAA that not only meets the current needs of your project, but also has the flexibility to grow and evolve as your project progresses. This thoughtful and strategic approach to designing your TAA will help ensure that your automated testing efforts are efficient, scalable, and capable of delivering high-quality results throughout the lifecycle of your project.